So to determine which element in a bond, either ionic or covalent, to determine which element is more likely to attract electrons, or in an ionic bond, which element is more willing to donate or accept electrons, we need to refer to this concept called electronegativity, which is somewhat similar to electron affinity that we talked about in Chapter 7. By definition, electronegativity is the ability of an atom to attract electrons in a chemical bond. And it's really, as it says here, important to determine ionic and covalent molecular compounds. So what I have here on the screen is an electronegativity table with quantitative values that speak to how much an atom wants to hog electrons in either an ionic or covalent bond. The bigger the number, the more electronegative the atom. So you see that fluorine is the most electronegative atom. And you see that there's a general trend of increasing electronegativity going from left to right and bottom to top. So looking at this, we can see with our potassium chloride example, potassium, it has an electronegativity of 0.9. Chlorine, 3. It is a lot more electronegative than potassium, so potassium will certainly want to donate its electron to chlorine because it is more electronegative. So this electronegativity table, you will be given one for your exam. So you don't need to memorize it, you just need to know how to use it and the definition of electronegativity. And the way that we can use it is to determine if a particular bond, in this case, is polar. And when we talk about polarity, we essentially mean, is there a separation of charge in that bond? For example, this HCl molecule, hydrogen bonded to chlorine. The way that we've written that bond there, we are assuming that those two electrons are shared equally. Well, we now know that is not the case because chlorine has a much more electronegative value than hydrogen. So we would show that polarity of the bond, or that difference in electronegativity, by writing something called a dipole. Dipole can be written one of two ways. The most common way is an arrow pointing from the least electronegative atom to the most, with a little plus sign towards the atom that is least electronegative. Sometimes dipoles can be shown with this little sigma plus and sigma negative. Both of them show that this molecule is polar. There's a partial negative charge and a partial positive charge due to differences in electronegativity between atoms. Okay. We can calculate what that difference in electronegativity is by doing a quick calculation of delta En, using the electronegativity values from the table, always doing the bigger number minus the smaller number. So in this case, the change in electronegativity, or the delta En for this HCl bond, 3 minus 2.1, or 0.9. And doing that can be handy to help determine if a particular bond you are dealing with is polar. Being able to calculate the change in electronegativity, as well as using these guideposts as these ranges to say something about the type of bond. Is that bond primarily nonpolar covalent, where there's essentially equal sharing of both of electrons in that bond between two atoms? Or is it polar covalent? Are there uneven shared electrons? Or is it ionic? Is that electron completely transferred from one species to another? So you should be able to, given a periodic table or given an electronegativity table, be able to calculate the delta En for a particular bond, and you should memorize these ranges as guideposts to help you determine if a particular bond is nonpolar covalent, polar covalent, or ionic. In the next video, we will start to talk about some terms that are important with regards to Lewis dot structures, and then we will actually start to draw Lewis dot structures for molecules.